So good morning all. Today we are going to discuss how to use the class for creating a node and linked list. If you are watching this session, I request you to first watch the linked list part 1 for MCA. In that, I have shown how the structures are used to create the node and create the node, and direct function without any class, how the direct function can be written. But here we are going to do everything class based. Okay, so first watch the previous slide, linked list one, where I have given the basics of linked list, also very basic, so that are very important to understand this particular logic. So I will begin with this session. Welcome you all. So previous session I have shown that how a node can be created using the structure. Okay, so you can see here we have a declaration of the structure, and name of the structure is link node, and this structure has two parts, data part and link part, that is shown in this node. Data part and the link part should be the two parts. So data part I have shown integer, it can be a single data, that is homogeneous data, or data part can be heterogeneous data, where you can have multiple kinds of data, different data types, you can create the data. So in our examples we have only single data, so it's a homogeneous node. And the link part, you are creating a link as a pointer to the same structure, where the structure name is struct link node, so same structure you are used, and the pointer should be the same structure. And you are giving one alias to this entire structure by using type def. Type def means you are giving the alias name, and the name is node, so you will be creating the pointers for that node only. Okay, now how can you use the class to create the same node? So class node is the name of the node. So this class node, and you can generally can declare the public or protected, because we are going to create linked list class which will be inherited from this node. So this is going to be the parent node or the base parent class or the base class. Okay. This class has two parts, data part and the link part, so which is required for the node, data part and link part. Link is the pointer to the same class. That means it is pointer to the same node. Okay, and there are two functions, get node and pre node. Okay, get node will create a new node and return the pointer to the node, so node star is the return type. Pre node, you are passing the node pointer, and the node to that pointer will be destroyed by free node. So two functions we have, get node and the free node functions. Okay, that is part of the class. Now get node function, which already we have discussed, once again we'll see get node function. So get node function can be written like this. In the previous session I have shown the get working of the get node, but it was not belong to any class. Now get node belongs to the class node. So you're saying node scope resolution operator get node. So that means get node is a member function of a class node, and its return type is node star, and the rest of the code will remain same. So how the get node works, if you have to understood, you have to watch my previous session, which is says linked list part 1, and you can give as MCA RNSIT in the search, so you'll get that linked list part 1. Okay, now this is the get node function. Now we have seen how the node can be created using a class. Now how the linked list, you can construct a class for the linked list itself. Okay, a class for the linked list itself. So this is the class called linked list, and this linked list class is inherited from the node class. That means the data part and the link part is directly available here, and the get node and pre node functions are also available to this class. Apart from that, the linked list has two sections, private section and public section. Private section creates the start pointer, so it's the beginning of the linked list. Okay, so this is the pointer that points to the linked list. Okay, and in the public part, all the functions that can be applied on the linked list class. So like linked list is a constructor which will be responsible to set the list to empty. Then you have insert front, insert end, insert before, insert at position, display, remove front, and so on. Okay, all these are the functions that you can write, and more functions are also possible. Insert front is responsible for inserting a node in the beginning of the linked list, which we have discussed already in the previous session. Insert end is responsible for inserting a node at the end of the linked list. And insert before the key element means you are going to insert a node before the input key. Okay, you have to search that key in the linked list and you have to insert the new node before that key, and so on, other functions. So we are going to concentrate on first three functions. Okay, so insert part only we'll discuss first and then we'll go for the delete. Okay, so today's session will be insert end because insert front is there in the previous session. You can watch that session. So here one of the important member function of the class is the constructor. So the job of the constructor is set the linked list empty. So how to set the linked list to empty? You have to say start equal to null. So name of the constructor is the name of the class. So class name is a linked list and the constructor name is also linked list. So this tells that this constructor belongs to the class linked list and no return type to the constructor. Constructor will not have any return type. And start equal to null means list is empty. And generally, if you have to say call insert front or insert end function or insert before key or delete front, whatever you want to call, you have to write a menu for that and ask the user to what menu he want to go for. You have to read that choice and call the functions accordingly. So in this function main, first thing is linked list space list. You are creating the object called list here. Okay. So this list object will be storing the start pointer. Okay. So this is how you will write the main function, and the while condition is always true here, while one. Here you are displaying the menu like 1 for insert front, 2 for insert end, 3 for display, 4 for say insert before key, and so on. All cases you can write here. Okay. So I have written dot 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 because there are many cases, so you have to add it. Then read the choice from the user, enter your choice. You will say suppose choice is here 1, then you will be calling insert front. If the choice is 2, you will be calling insert end, and so on. Okay, suppose choice is 1, then what is that? You have to insert the node before the in the front of the linked list. Okay, you have to insert the node in the front of the linked list. So first you have to read the node value. Okay, you are reading the node value, and then you are saying list dot insert front element, pass the element that should be inserted. Okay, if the case is 2, that is your choice is 2, then case 2 will be true. Then also you are reading the element because you have to insert the node. So read the node value and call the function as list dot insert end element. Okay, that's how. Okay, and that particular function will run. Now insert front function we have discussed in the previous session, but it was an independent function. Now insert front will be the member function of the linked list class. So this is the linked list class and return type of the function is void. Rest of the code will remain same, no change to the code. Okay. So insert front I am not going to discuss in this session. It is, if you want to watch, you watch my previous session. So insert front we have done. So today our discussion will concentrate on insert end. Okay, insert a node at the end of the linked list. So first we'll see the logic, how the node can be inserted at the end of the linked list. And the situation is, suppose we have already some nodes are exist. So node 1 is at address 200, node 2 is at address 300, node 3 is at address 400. And start is storing 200. That means start is pointing to the first node whose address is 200. So logic says first create a new node. Okay, create a new node. So you will create a new node in the heap. Suppose the new node is constructed at the address 500. So temp will be the pointer pointing to that node. The pointer name can be anything, it's your choice. Then search for the last node. Okay, search for the last node. So in the linked list, you have to search which is the last node. So this is your last node. So you require a while loop or for loop to search this node and mark it with the last pointer. So last pointer will point to the last node here. Once the last pointer is pointing to the last node, then you can go to the third step. You can say last arrow link equal to temp. So this is the last which is pointing to this node, and the link part will change to temp. So what is temp here? Temp is 500. Okay, temp is 500 means this temp will be copied to this link part. Okay, so that means what is the value that comes in that link part? So this link part will become 500. Okay, so 500 means this is pointing to this node. Okay, that means the node is inserted. The new node is inserted in the linked list once this link is created. Okay, so now when you come out of the function, what happens to these pointers? The pointers will be destroyed. Okay, so you can see the linked list where the node is inserted at the end of the linked list. So here the important part of this function will be searching the last node. So you require the loop for that. Okay, so we set initial value of the last pointer first. So setting initial value of the last pointer means last pointer should set to the beginning of the linked list. So how will you do that? So that you can do by saying node star last equal to start. So what is the meaning here? Start value will be copied to this last pointer. Okay, so that means this 400 will be copied here. So if 400 comes here, this last will be pointing to this node. Okay, that is how it will work, this particular line. So we'll see what value will come here. We'll get 400 here. Okay, so once 400 comes here, this is pointing to that node. Okay, so next, once this has been done, then we require the while loop so that this last should go to the last node. Okay, so each time you have to move this last pointer by one node. Okay, move this last pointer each time by one node till you encounter the node whose link part is null. That means you have to each time check the link part, and if link part is not null, keep on moving this pointer. That means what is the while loop you require? So this is the while loop you require here. So this is the while loop. So we'll see how this while loop will work on this example. So first you will start with this while loop and you will check what is last arrow link. So what is last arrow link? Last arrow link is 200. So 200. So is it not equal to null? Yes, it is not equal to null. 200 is not equal to null. So condition is true. So we'll come here. And remember this code. This code, whenever we say pointer equal to pointer arrow link, the pointer moves by one node. So saying last equal to last arrow link, okay, will move the last pointer by one node. So the last pointer will move by one node. Okay, it moves by one node. So how exactly it moves by one node, that also we'll see. Okay, so the code says copy this last arrow link to last itself. Okay, so what is last arrow link? This is last, this is arrow, this is link. So right now last arrow link is 200. This 200 will be copied back to last. So that means this 400 will be replaced by 200. Is it clear? So that is the meaning here. So that means if 200 comes here, the last is pointing to this node. So it moves by one node. And again you will check the while loop. Again check the last arrow link whether it is not equal to null. So check the last arrow link. Yes, it is not equal to null. Condition is true. So it will come here. Again the last pointer will move by one node. So whenever the last node is not pointing to null, so it is not null, means it is moved by one node. So it moves by one node. So last is now pointing to the node with address 300. Okay, again check this while. Now what is last arrow link? Last arrow link is now null. So null not equal to null, condition is false. Okay, so if the condition is false, so what does that mean? This particular code is responsible to move the last pointer to the end of the node. So last is pointing to the node. So that is how this particular code will work. So you can remember this code. This code is responsible for setting the last pointer to the last node. So we will not repeat this code once again in the program. We just understood now that this code will make sure that last is pointing to the last node. Now we'll start from the beginning. Okay, how does the insert last will work? So we'll start from the main function. We'll come to the first line. We are creating the object called list. So creating the object, will call this constructor. This constructor will set the start pointer to null. So this list object, so list is the object where start pointer will be set to null. Okay, so this list object has the start pointer and start pointer is set to null. Okay, So that is done by the constructor. Then you will come to the while loop, and while it's true, so you display the menu. Okay, so 1 for insert front, 2 for insert, and so on. And you have to read the choice and assume the choice is 2. 2 means insert end. Choice is 2. Then case 1 will be false. It will go to the case 2. Okay. In the case 2, you have to read the element and assume the element is 50. Okay, element is 50. So once reading the element, it will come to the function call. So you're calling the insert end function and the element is 50. So your function call will look like this: list dot insert end 50. So function will be called for the element 50. So you can see list dot insert end 50 will call this function. So this function will start execution. And our situation is list is empty. Initially list is empty. So it will come to first line. So you already know what is the first line. It simply creates the new node in the heap and its address will be returned to temp. Okay, so node is created at address 500 and the temp is 500. Then you have to set the data part with the val. What is val? Val is 50 that you have already passed here. So val is 50. So that 50 will be set in the data part here. So you can see this data is set to 50. Temp arrow data is set to 50. And it comes to this condition. Okay. So this condition is true for always this situation. When the list is empty, this condition is true. Why? Start is null. So you can see in the example, start is null. So condition is true. So start equal to temp will run. So what is meant by start equal to temp here? So temp value is copied to start. Okay, so what is temp value? This is temp value 500 that is copied to start. So null will be replaced by this value 500. Okay, so you'll get 500 here. So if 500 comes here, that means start is pointing to the newly created node. Is it clear? So now it is pointing to the newly created node. And next return statement will run. So what is meant by return? Okay, return means you'll come out of the function. Okay, so when you come out of the function, the local pointer temp will be destroyed. So you can see the node is inserted in the linked list. Okay, because there was no node earlier. Now the new node becomes the first node. Even though it is inserted, it becomes first node because you have no node earlier. Okay, now we will call the function again for insert end of 10. So say this is situation 2. There is one node and you are calling the function insert end for 10. So you'll come to the first line, create a node, new node. So new node will be constructed. Suppose at address 400. So temp is 400. So set the data part. So what is the data part? The value passed is 10. So data part will be 10. Okay, data part becomes 10. Then it checks this condition. Is this condition true? Okay, this condition is not true. This condition is false because start is having some value now. It's not null. Condition is false. Now we come to this set of code. This set of code already we have discussed. What does this set of code does? It says the last pointer to the last node of the linked list. So we have only one node in the linked list and that itself is the last node. So the current, this last pointer will be point to this last node. Okay, this pointer is pointing to this node because there are no more nodes. So at the end of this code, the last will be pointing to this node. Then it comes to this line, last arrow link equal to temp. So what is last arrow link? This is your last, this is arrow, this is link. So last is pointing to this node means the link part of this node is accessed and this link will be the value of temp. So what is temp? Temp is 500. So I'll show here the temp is copied to this link part. So this link part will change with what value? Temp value. So temp value will be copied here. Is it clear? So this is how it will work. So see now temp is 400. So you'll get here 400. So once 400 comes here, this node is pointing to the next node, that is newly created node. Okay. Then you will come out of the function. So at the end of the function, temporary pointers will be destroyed. So there are two temporary pointers, last and temp. Both pointers are destroyed. So you can see the linked list has now two nodes and the new node is inserted at the end of the linked list. So function says insert end. So it works according to that. Now we'll go to the situation 3. Situation 3 is, suppose there are already some nodes available. For example, we have 3 nodes. Okay, and first node is 50, second node is value 10, third node value is 20, and they are created at address 500, 400, and 600 respectively. So start is pointing to the first node, and you want to call the function with the new node now. So suppose the new node to be inserted is with the value 30. Okay, now new node has to be created with value 30. So we'll go to the first line. Okay, so we'll go to the first line. So first line is what? Temp equal to get node. So one node is created. Okay, one node is created at address 100. Set the data part. So data is 30. So data part is set to 30 here. Okay. So if condition is false because start is not null, this part of the code, it will set the last pointer to the last node. This is already we have traced in the beginning. So that first last will be pointing to the first node, then keep on moving till it encounters the last node. So at the end of this code, last will be pointing to the last node. Okay, so this is the part of the code that will set this pointer to the last node. Then it goes to the last line where you have to create the link between this node and the new node. So last arrow link equal to temp. So temp will be copied to this link part. So temp is 100. This is copied to this link part. So this link part is pointing to the new node. Okay, so link is created. Then will come out of the function. These pointers will be destroyed. So you can see again the node is inserted at the end of the linked list. So here I will end up the session. So what we have discussed is how a node can be inserted to the end of the linked list. Okay. So all of you practice this. Okay, part in the linked list part 3. Okay, for RNSIT MCA students. I am going to explain in the next session how the node can be inserted before the given key. Okay, that I am going to discuss in the next session. Thank you all.